Hi everyone, my name is Keith Bauer and I'm a structural engineer with Bueller based out of Sacramento. And what I'm going to be doing today is walking you through how to read a set of structural drawings. You're going to need to be able to do this for your scavenger hunt that's part of this year's program. First, there's a video that we're going to provide you a link to that kind of gives you a good overall understanding of drawings and view types, just on a general level. And then we're going to kind of take those lessons that you've learned from that and apply it to a set of structural drawings for an actual building design. Now, this building was never actually built, but it was designed and permitted about 10 years ago. And so what we're going to do is kind of walk through how to read this set of drawings. And then it will help you answer some of the questions that'll be coming up in your quiz. That's part of your scavenger hunt. Now, when you think about drawings in general, the first thing you want to do is read the cover sheet. The cover sheet has a lot of good information on it. There's general notes on there, and those notes apply to the entirety of the set. So you'll see things in a structural set that apply to different materials. Things like concrete and concrete strengths, steel and the type of steel that needs to be used. And then also things like design criteria and the loads that we have to design for. So that'll be on the cover note or the cover sheet. That generally is followed by a couple of typical detail sheets. So if you ever see a set of drawings and at the top of the sheet it says typical details, what that means is those details apply to the entire project, and they don't necessarily have to be referenced anywhere. So you kind of have to go and look at all of those sheets, look at all the details, really look at the titles of the details and what they represent, and then know that they apply, whether or not they're specifically referenced. We'll talk about what referencing means here in a second too. Then you have plan notes. Now, plan notes, they're just kind of notes that describe things on the plan, things like what symbols mean, so it's like legends, other descriptors of important stuff that you would need to know in terms of, for structural drawings, foundations are based off of a geotechnical report and the values that the soil has. That report generally gets referenced in the plan notes. Things like that, and we'll show you an example. Then you go to the plan sheets. Now, the plan sheets show you what happens at each floor. Structural drawings are generally broken down by foundation plan, which shows you what the on-grade condition is. It's generally some sort of a concrete slab supported by footings. Then you have elevated framing plans. So in this building, it's a 4-story building, so you'll see floor framing plans for the 2nd, 3rd, and 4th floors. And then a roof framing plan that shows the framing of the roof. What these show, in general, are members, types, and sizes. So in this case, it's a steel building, so they're using steel wide flange sections, so it'll call out the sizes of the beams. It'll show you what the floor section is. For a steel building, typically we use what we call concrete over metal deck. And you can look up what that means, but it has a thickness to it and generally has reinforcing in it, and that will be specified on the drawings as well. Other important information would be elevations, so the height of the floor. You'll see a symbol FF, which means finished floor, so it'll tell you what the finished floor elevation is in terms of height relative to the ground level, which typically would be 0, 0. So you'll see lots of information on the plans. In addition, the plans will have a bunch of symbols. And you can see on my screen here, this is kind of a 2-sheet summary that you'll be seeing. You'll see some symbols like this, where you'll have sections or elevations. Those are different view types, which you'll understand after reading or viewing this video that we're going to give you a link to. But a section is basically like cutting a slice through the building. And that provides you a little bit more information in terms of the geometry and how things go together. Elevations, or if you're like taking a look at the front of a building or the face of a building. So like if you walk up to your house and when you see your front door from the street, that would be the elevation at the front of your house. And then last but not least, your details, where details are called out with bubbles like this. And there's different ways to go about it. But in general, details are blow-ups. So they're showing very, very detailed and granular information about things like connections, number of bolts, number of screws, things like that for a structural set of drawings. So as you go through this, you're going to go through the plan sheets. You'll get these references via these symbols to section and elevation sheets. And this kind of describes how they're labeled. So you see the top thing is a number in general for a detail. So this would be like 1, and then a sheet label, something like S5.3. We'll show you how to look through that as we're going through this a little bit farther. And then you get into detail sheets, okay? So you're gonna get this list of questions, and I'm actually gonna walk through a couple of these, and then when you get the final version of this, you'll see that it has some hints, maybe some guidance as to where to start. But the goal is not to just kind of haphazardly kind of scroll through the drawings and look for the answers. The goal is to really understand how to get from the notes to the plans to the sections or the details or whatever the case may be to really find the answer. We want to make sure you understand the path of how to read drawings. This is something that if you stay in the field as a designer or on the contracting side, you're going to have to be able to do. And it's good to get exposure to it early. As a little bit of a reference, I used to teach at UC Davis, and I used this same exercise as a homework assignment for a class of graduating seniors that were all structural engineering majors. And even by the time they get to this level in college, they hadn't, in most cases, seen a set of drawings yet. So the sooner you can get exposure to what a set of drawings looks like, and in the future, we're going to be looking at doing like a mechanical set, electrical set, architectural set, so you get a better understanding of how to read all different types of drawings. But the sooner you get exposure to this, the better off you'll be. So let's take a look at the set of drawings. We'll kind of walk through it specifically. So the set of drawings you're going to be getting, it's actually 24 sheets, and they're going to all be labeled. So you're going to want to use some sort of a PDF viewer, whether that's Bluebeam, Acrobat, something along those lines, to view these things. But just like we described, the first sheet is the general notes sheet. You can see it's labeled at the top here, general notes. In general, there's a bunch of stuff in here. In a lot of cases, it's just a bunch of legalese and notes that the contractor has to be aware of. But where things start to get important are things like this, the abbreviations. Drawings use a lot of shorthand notation. And so in general, you'll see on most sets, you'll see an abbreviation list, which indicates what things mean. Now, earlier I mentioned FF is finished floor. So you'll see that a lot, but you'll see lots of other things like GA is gauge. That's thickness of material for things like metal studs, which you use for wall framing. You see this one a lot, UNO, unless noted otherwise. One that'll come up and actually comes up in your quiz is TOS for top of steel. TOF is top of footing, or it could be top of framing, depending on the use. So you want to make sure you review this abbreviations list, and if you see something that looks like an abbreviation later in any of the notes on the drawings, always refer back to this and see if it's in here first. If it's not in here, hopefully it's something that's pretty obvious and you can figure out without this index, but this is always a good place to go back to. We'll also show design criteria. This is required by the code that we have to say what kind of loads we're designing to. I don't think there's any questions on this in the scavenger hunt, but it's kind of useful to know that, hey, roof live load, that's for people walking on the roof. It's designed for essentially 20 pounds a square foot. That seems light, but actually it's pretty conservative in the grand scheme of things. The other things that you're going to look at, there's a lot of stuff in here that you guys don't necessarily need to know at this level, but so we're talking about different materials. So there's a whole set of materials or notes on concrete, and there's things like material strengths. Hint, this is foreshadowing because you get a question on this, where this is talking about the strength of concrete for different types of elements, foundation, slab on grade, concrete fill over metal deck. So this is something you're going to want to take a look at. So I have one for concrete, we have one for steel, and then there's some other things too, like very specific powder actuated fasteners. Those are shot pins. It's basically a peg that gets driven into the ground or into the steel that connects wall framing. But take a look and review all of these general notes. As you advance into the set, now we get into some typical detail sheets. And typical often appears in the title of the sheet, so you can see S1.2 is just called typical details, right? But what really makes it a typical sheet, whether or not it's named as such, is, for us, this heading at the top. So it says typical details, applicable to all drawings unless noted or shown otherwise. So what that means is the contractor is responsible for reviewing, reading, and understanding all these details and applying them wherever they need to be applied without being actually told where they apply. So they have to understand, and it comes with experience, they have to understand where these things come into play. So you'll see things in here, like as an example, this is a typical masonry wall reinforcing detail. And what it does is it shows like, hey, when you come to a T intersection at a wall, what kind of reinforcing steel do you need to add? So it says ADDL, that's additional. You'll see that in the abbreviations list. VERT is vertical reinforcing, typical at corners and intersections. And number 5 is the size of the bar. So you'll see that, hey, when you come to a T intersection, there's some extra bars. Where you come to the end of the wall, there's some extra bars. When you come to a corner, there's some extra bars. So it's just kind of a theme. So the contractor will have to go through this and understand all these types of things. On this particular set, there's 4 sheets of typical details at the front. I mentioned earlier, like gauge is a thickness of material. That's for metal studs. So if any of you have seen like a non-residential building, or at least not a house, most commercial buildings, the wall framing is made up of metal studs. Just because they're truer, they're flatter, they're easier to work with. They're a little bit more durable. So this is kind of showing how we frame out walls, whether it's an interior wall or, in the case of the next sheet, an exterior wall. So you'll see things like this, and these are all detail views now, right? And unless it's called out in elevation, so you're looking at the face of the wall, it's showing all the different sticks that make up the wall framing. But in general, most of these are details. And so they're showing really very specific information. Things like anchor bolts. How are these walls tied down to the foundation? If you're sitting on a curb, what kind of reinforcing is in the curb? So there's a lot of information like that in these details. You talk about other things. This one, SMS, is a sheet metal screw. You'll see that in the abbreviations list, but it's saying how many screws attached, this wall to this clip, which attaches it to the floor. So these are the types of things that you'll see in detail views. Just scrolling through the rest of these really quickly. One I want to point out is something called backing. Backing is something that, when you have cabinets or equipment or handicap grab bars or things like that need to attach to the wall. To make it easier for them to attach so they don't have to hit a stud, right? You got studs in the wall, they're 16 inches on center, 24 inches on center. It's really hard to find where those are and then get a screw through the gypboard or the sheetrock of the wall into the stud and knowing that you're hitting it. So oftentimes what they'll do is they'll provide something called backing. And backing provides more continuous support. So this spans between the studs, and there's actually another view of it on another detail, 13S1.5, where it tells you what this is, but it gives contractors a wider surface that's easier to hit for attachment of things like equipment or cabinets. So 13S1.5, you guys might need to know that detail for the scavenger hunt as well. Then we get into the plan note sheets. Sometimes these notes actually occur on the plan sheets. If there's not room, they occur just on their own sheet. But this is where you see things like, hey, you need to take a look at this soils report for the foundation design. It gives a bunch of detail or section or elevation references where you might find more information on things that are based off of these symbols. So it's kind of like a legend. You see stuff like this, TB. So if there's abbreviations that aren't in the abbreviation list that are specific to the project, things like TB, which is a tie beam, or GB, which is a grade beam, this tells you where to find information on those elements. Similar to what was shown in the upfront information, this kind of describes, hey, this is an elevation view. So it has an arrow pointing at the face that you're looking at, and then it identifies, hey, the number is the reference number of the elevation. We'll show you an example of that in a little bit. And S4.1 is the sheet that you'll find that. So we'll take a look at that in a second here too. Then you get into the plan sheets. Now, the first level is always the base or the foundation, right? You start at the ground up. And so the foundation plan shows a lot of information. A couple of things you'll see on the foundation plan for this. The column schedule. So it tells you what the size of the columns are. So think of this as like an elevation of what the column looks like over its height. So at the bottom is TOF, top of footing, is 1'6" below the finished grade. And then the top of steel for the roof elevation, even though it varies. And it gives elevations of all the top of steels for the different floors, okay? So if you look at something like this is showing a column that goes from just above the second floor up to the roof, and it calls out its size, which is W12 by 50. So in general, these things are identified on plan. When you look at the foundation plan, you'll see these little ellipses. It says like C2. That means C2, you can go straight to the schedule, see the C2, and that'll show you what the column size is over the height of the building. It'll also reference you to a detail for the base plate. It's further redundant in terms of column locations. So column locations, and what's really, really important on drawings, are grids. Grids define, in general, they define things like column locations or wall locations. It helps the contractor build the building. So when you look at stuff like this, you'll see a bunch of bubbles that have letters and numbers in them. So if you see something like, hey, grid A2, you go over to the left side, you look for A, you come across until you hit 2, that's grid A2. It's a column type C9, okay? We'll also show dimensions and such on the foundation plan. There's information about what the concrete slab on grade is going to be. In this case, it's 4 inches. If you see a hexagon, that's telling you a footing size. And it points you similarly like the column symbol does, it points you to a schedule. So we have a footing schedule right here that has different sizes. So like a type C footing is 20 feet wide by 12, or 20 feet long by 12 feet wide, 36 inches or 3 feet deep, and it calls out the reinforcing. If you see a superscript like this, that means it's pointing to this note. So this note's just talking about grade beam reinforcing passing through those footings. And I don't think you need to know that for your scavenger hunt. But take a look at this and look at the types of information. Again, you'll see things like elevation symbols, 1S4.4 or 1S4.1. Those are going to be showing you some very specific information on those sheets. Let's go to one of those right now. Let's go 1S4.1. When you talk about a frame elevation, this is what we're talking about. So frame elevations are typically used to show lateral force resisting elements, and that's more than you guys need to know right now. But in general, structures have to withstand vertical and lateral loads. Lateral loads are generally restrained by either braces or what we call a moment frame. This is a brace frame building. And so this elevation shows you all the diagonal braces that we have in the building. It tells you what size they are. BRB stands for buckling restrained brace. It's a very specific type of brace. And the 8 is the size of it. And we won't get into that too much either. But then it has detail references to the connections. So if you look at like 9S4.2, you go to, in this case, it's 4.2A. There used to be an A and a B in this set. But if you go to 9S4.2, it shows you what that connection looks like. Again, a lot more detail than you guys need to worry about right now, but it's kind of fun to look at, where you see you got a base plate, the column comes down to the base plate, it's got anchor bolts that tie it to the footing, and then there's this plate that the brace attaches to, that's called the gusset plate, and it shows a bunch of information about the gusset plate. These little symbols, when you see triangles and flags like that, those are weld symbols, so it's talking about what kind of welds it means. And then it's calling out a bunch of other information too, in terms of the geometry, about the angle of the gusset plate and how they actually size what it is. So, interesting stuff. At least I think so. So that's what the foundation plan shows. It'll show your column sizes, your footing sizes, and a bunch of dimensional information and reference other sections, details, and elevations. Similarly, you'll go up to the framing plan. So in this case, we've got the second, third, and fourth framing plans. The third and fourth plans, they're the same, they're identical, so they're combined here. And the second floor framing plan is a little bit different for whatever reason. It looks like this area might be a little bit different right here. But what these do is they show beam sizes and locations, deck sizes and profiles, and then provide a bunch of references back to details. So, finished floor elevation, 15 feet. This tells you the top of the second floor, the concrete at the top of the second floor is 15 feet. And then we'll show you a section of what that means in terms of where the steel is. But then as you get into it, it's showing you beam sizes. So when you talk about wide flange beams, they're always called W shapes. And it's a W 16 by 31. That means it's 16 inches deep. It weighs 31 pounds per foot. And there's nothing in these drawings that'll tell you that. That's just standard that everybody, by the time you get to the level that you're designing buildings, you know. And then this will be in the plan notes as well. This 24, that means that's the number of studs that are on top of the beam. There's little pieces of steel that get welded to the top of the beam that get embedded in the concrete floor slab to tie them all together. And then C equals 1 inch. Again, this will be defined on those plan notes back on S2.0. And I'm not going to tell you guys what that is. You guys have to look that up, because that might be one of your questions. In any case, you'll see a lot of information like this. So you will see beam sizes, elevations. In some cases, there's some extra reinforcing. So drag bars, that's extra reinforcing, represented by this dash line. Those are along the lines where we have some frames, so you can see there's a frame. If you see a little angle with a little squiggly guy like this, that's just showing that there's a brace that's going up from this floor to the next floor. So that's something to keep in mind as well. But you'll always be able to see what that is going back to the foundation plan. There'll be an elevation that shows where that brace is. So those are the important things that you want to see on the roof or the floor framing plans. The roof framing plan is very similar. So here's our roof, and we have a little high roof because there's a pop-up where the stair goes up to the roof, and we need to provide a roof over that. There's some other things that you see on these typically. This area right here with this big diagonal hatch, these are all mechanical units. So you can see here, this is called out as condensing unit, tip of 6. So there's 6 mechanical units right here. And this is a big air handler, air conditioner. One thing we didn't talk about on the floor, but it is something that happens on the floor and the roof, is you'll see a little symbol like this that looks like some corrugations or metal deck. If you've seen what metal deck looks like, it's calling out 3.5 inches of NW, which is normal weight concrete over metal deck. The 3 inch by 20 gauge is just the depth and the thickness of the deck itself, and then reinforcing. So keep an eye out for stuff like that. And then this is, when you see clouds on drawings, this particular set, there are things that were revised during the permitting process. In this case, some beams were added, it looks like. And so those were clouded just to point out to the authority reviewing them that, hey, we've got something new here you guys need to take a look at. You look at building sections, it's just a cut through the overall building. Remember, I said it's like cutting a slice through the building and taking a look at it. So we like to, for a lot of buildings, and this is not necessarily specific to Bueller, but not everybody does this, cut an overall section just to kind of give you, or the contractor ultimately, an idea of what the building looks like overall. And we'll have these little keynotes on them with numbers and ellipses pointing at things that come back up to this list. And again, it's just another way to provide more information. So saying, hey, wide flange column C foundation plan in AS 2.1, that's that column schedule. So it'll tell, it's just a reminder to the contractor, look at the column schedule for the column sizes, or the footing schedule for the footing sizes. So not a whole lot of information here other than this is a way that you can go ahead again and see where the finished floor is. Now we're talking about concrete over metal deck earlier. This is what it looks like. So you have, when it says 3.5 inches of concrete, that's the thickness of the concrete from this level up to the finished floor. And then the metal deck thickness over a 3-inch deck, this is a 3-inch thick deck. And so it's just representing this, showing this geometry wise, but it tells you, hey, as a way to take a look at it, it's showing you where the column splices are, where those occur. It shows you the finished floor elevation. It shows you the top of steel. Because of the thickness of this concrete over metal deck, it sits 6.5 inches below the floor. And that's typical on this project. Then you get into more specific sections. So this is where you're starting to see some more detailed information. These are some sections through various areas of the footing. And these will all be referenced on plan, but we'll start to show things like reinforcing. We show it graphically. This one is an elevator pit. So generally when you have an elevator, there's a pit that extends about 5 feet below the floor. There might be a question on that kind of gets you to this section where it's talking about wall thicknesses and reinforcing. That information you'll find in our sections. Some other kind of useful things as you're working your way up. So this is all foundation related information. And generally we do our sections in order again from bottom up. So you'll start with the foundation sections and kind of the second floor. As you work your way up, you'll see it's just the elevated floor. So this is typical probably at the second, third, and fourth floors. And we're showing things like closure plates. So when you pour your concrete, there has to be something that stops the concrete from just falling over the edge. So we have a detail that tells the contractor how to build that. A soffit, that's just something like it's built out of metal studs and sheetrock. And in this case, it's just encasing that beam, so it's hiding it. So you'll see different things in here talking about some architectural items. Century metal panel, that's the type of exterior cladding that they use to enclose the building. Shows again this concrete or metal deck with the reinforcing that's in it. You'll see there's generally a couple extra bars at the edge. It's good detailing practice. But as you work your way through all these sections, you start to see more information that takes you all the way up. In this case, you'll see a lot of stuff was removed. Once upon a time, the first version of this building, there was a roof deck up there, which would have been super cool, but it turned out to be too expensive and it got pulled out of the project. So there's a lot of sections that got pulled out. And if you see a little delta like this, triangle, that's a delta, based off the Greek alphabet, but it points you back to the title block where these deltas will say, hey, when did that change occur? And that change occurred in November of 2013. A couple more sections. Again, most of these are up at the roof, so that's why a lot of them got taken out, because there are a ton of sections specific to that rooftop deck that's no longer there. This is, again, the frame elevation. We talked about that briefly before. So this is the one that was on the left side or the west side of the building. And then these are the little short guys that you see kind of running. I'll show you where these are real quick. Going back to the foundation plan, you'll see that there's this elevation call out 2S 4.1 similar. Sim is similar. So it's pointing at this area. That's what's being shown in this view, is that frame. We talked about 4.2. If you see any references to 4.2, it really means 4.2A in this project, because I said we had two alternate types of details. There's a 4.2A and a 4.2B, and we were leaving it up to the contractor to choose which one they wanted to use. Ultimately, they decided they're going to use A, so we just took out the other sheet. S4.3 shows some more details, so this is specific to some of the foundation type stuff and some of the steel connections related to these braces. And then here's something else that's pretty interesting that you're going to have to look at. So the foundations for this building, we had to use some grade beams. And what grade beams are, they're really beams below grade. So that's how they get their fancy name. But it's basically a concrete beam in the slab, or below the slab, that we're using to support our columns. Let's go back to the foundation plan real quick and take a look at that. So you'll see in a few locations, you'll see this entire thing that's running along this elevation. And the grade beams are actually called out. See, 1S4.4. So we talked about 1S4.1 showed all the braces and such. And then there's another elevation here, 1S4.4. And you'll see these on all four sides of the building. There's a grade beam that wraps around the entire perimeter. So based off of where you're looking, so if we're looking at the west side of the building, we go to 1S4.4, and that shows you what this grade beam looks like. And it's defined by grid location. So you're saying going from grid A all the way down to grid, I believe, F is the edge of this building. And it tells you what all the reinforcing in the steel is across here. So when you see bot, that's the bottom bars. Top is just top bars. 6 is the quantity of bars, and number 9 is the size of the bars. And in general, this is a little detail you guys don't need to know. You have to splice bars, so you can't just stop one and start another. They have to overlap so that the load can be transferred from one bar to the other, because we know we can't get, for as long as this building is, you're not going to get a continuous bar to run that long. So that's what the splice is all about. So it defines some other things. So finished floor is 0, 0, which is typical for the ground. The top of the grade beam, the top of footing, TOF, is minus 1'6" below that finished floor elevation. The bottom of the grade beam, BO grade beam, is 5 feet below. So that's telling you the grade beam is 3'6" thick. You'll also see some references to some of the sections. So we kind of already went through these section sheets, but AS 3.2, if you go back to S 3.2, it's showing you section A, and this is what the typical grade beam looks like. So it's telling you how wide it is, it's telling you where it is relative to the grid. So the grid goes right through the center of this guy. If we zoom out a little bit, there's your grid 1 comes down. So it's dimensioning where the face of the grade beam is relative to grid, which is really important for trying to build it. And it gives you an idea of what the reinforcing kind of looks like. So there's a couple of questions on that stuff, I believe. Then we get more into detail sheets again. And again, even though this isn't called typical steel details, it probably should have been, if I say so. And I did the set of drawings, so that's my fault, I didn't do it. But typical details, it says it up here again, right? Applicable to all drawings unless shown or noted otherwise. So this particular sheet is showing steel connection details. So again, you'll see things like the schedule. And what this means is, okay, you enter the schedule. We talked earlier that floor beam was a W16, right? So based off of a 16 by 31, you come in here and you want to know, hey, how does that beam connect to another beam? Well, it's W16. It says for plate thickness, T, thickness, and bolts, C, AS 5.1, it'll get you to the schedule. And that'll tell you that you need 4 bolts. And the shear plate, which is this plate right here, it's connecting the beam to the beam. This is going to be 3/8 of an inch thick. It's going to be welded with this little symbol that's kind of welded all around. So this plate gets welded to the beam with a 1/4 inch thick weld, and then it just tells you how many loads or how many pounds it can hold. You see 78.3 K. K is kips. 1 kip is 1,000 pounds. So this connection is good for 78,000 pounds, which is it feels like a lot, right? But that's pretty standard for these types of things. So when you look at this, steel connection details, the important things they show are typically the number of bolts, the spacing of the bolts. K is a property of the beam. You guys don't have to worry about that. But it defines the size of the plates and how all these things are connected together. You see different types of things. Any type of symbol like this with arrows coming off of a straight line that's either got a rectangle or a notch, or up above, triangle with a circle. Those are all weld type symbols, and that's telling you sizes of welds. And we're not going to get into that detail too much. Similar to steel connections, we'll have metal deck details that shows the deck, how it lays down on the floor. So it talks about the different type of deck we have. In this project, we only have one type of deck. So this is the designation, or kind of like the model type of the deck. This is the thickness and the depth of it. These are weld information. It's all stuff that they take back to the manufacturers. The manufacturers know what they're doing with that. We talked earlier about studs on the beams, right? And how they're studs that stick up into the concrete. So this detail right here explains what those callouts mean. So you got 28 in parentheses next to the beam. That means you have 28 studs, and they're 3/4 inch in diameter. If you see something like this, and there are callouts like this on plan, I can show you one in a second, where it's 40, 16, 14, or 40, 16, 40. And then it shows kind of graphically, see how there's 40 all clustered in this area, then 16, then 40. If you you want to see what that looks like in section, then this is what it looks like. Here's that stud. So the stud gets welded to the beam and it's embedded in the concrete. They pour the concrete around it and it ties the beam or the slab to the beam. And it helps actually strengthen the beam, makes the beam what they call composite. So you can use a lighter beam in conjunction with this concrete to support the loads. So let me go back real quick and show you one of those conditions where you see the dashed stud callouts. I believe we have a bunch on the side here. So W24 by 55, 848. So that means there's 8 studs from here to there. There's 4 studs from here to there. And there's 8 studs from here to there. That's all based off that detail. We got a couple other sheets of details. A lot of these are typical. Some of them are project specific. But it's things like, again, more connections. There's a thing here called a gooseneck, and I think this might be the only place it gets called out. It just says gooseneck. We call it a gooseneck because it kind of looks like a gooseneck. It's this L-shaped piece of steel that in this case we're using to provide support for the glass and the edge of the building, perimeter of the building. So there might be a question on that, what a gooseneck is. So some more detailed information, special reinforcing at the goosenecks as they come up. Sometimes you need to provide bracing for beams, so this is a bracing detail. Every now and then, if we're feeling nice, we'll let the contractor drill a hole through a beam so they can run things like sprinkler pipes. So this tells you how to put a hole in your beam. So kind of cool stuff like that. A couple more details, nothing super fancy here, and I don't actually think there's anything on this in the scavenger hunt, but don't quote me on that. It's showing some special connection type things. This is an architectural screen at the lobby, if you want to take a look at that. And then we generally have stair and elevator details, how the stairs have to be connected, and then support steel for the elevators. So in general terms, that's our set of drawings, right? So I kind of walked you through the whole thing. So let's go ahead and walk through a couple of these questions just for fun. So we'll help you guys out a little bit. So for each of the questions below, what we're talking about doing, we want you to give the answer, where you found it and how you got there. So again, it's not about just getting the answer right. It's really about learning how to navigate your way through these drawings. In a lot of cases, for some of these questions, you might have to look at 2 or 3 different locations. Like the first place you'll start is the plan will get you a section cut. You look at the section, it'll reference the detail. You go to the detail, that's where the answer is going to be. So kind of get used to that kind of flow. That's not always the case, but that's about as complicated as it'll get, that you'll have to go 3 steps to find the answer. In some cases, the answer will be real direct. So as the first question, so what size is the top floor column at the intersection of grid 3 and grid D? So the first thing you go, okay, when you're looking for sizes of members are generally shown on plan. Okay, so let's go back to the plan real quick. When we talk about columns, if you guys remember, we talked about the column schedule. This shows all the columns, right? So what you want to do, and I've already forgotten what location we're looking at, grid 3, grid D, got it. So we want to go and we find grid D, which is right here. We want to find grid 3, which is right here. You find the intersection of the 2, and that brings you to this location. So this is D3. You've got a few different things going on here. We got all kinds of stuff that we're showing. We have the section cut showing you what the foundation type is. We've got a detail for the base plate. We've got a column call out. We have a tie beam call out, and we have a footing call out. Lots of stuff going on, right? But what are we looking for here? We're looking for the column size. So this is telling us that D3 all the way up the height of the building, it's column type C1. We zoom out a little bit and we look at our column schedule. We look for the C1 right here, and it said we want to know what the top level is. So the top level is up here. That's telling you that column is a W12 by 72. So that's your answer. And so rather than just saying W12 by 72, then what we would want to say is something like it's W12 by 72 based on column schedule from foundation plan. That would be a complete answer. Okay? Tells you what the answer is, where you found it, how you got there. Let's run through another one real quick, just for fun. What is the concrete strength for typical foundation concrete on the project? Now, I kind of already hinted at this one. I sort of gave the answer away a little bit earlier, and that was semi-intentional. But again, when you're talking about material strength, that type of stuff, you're going to want to look on the general note sheet. So let's go back to the drawings. We go back to the general note sheet, big, huge sheet with all this fine print. But what we talked about earlier, right, there's a set of notes on concrete. And these notes cover all kinds of things. Clearance, where you install your bars. That's how far in from the edge of the concrete that your bar has to be installed. Talks about splices, talks about a bunch of stuff that we don't need to know about right now. But if you want to read through them all, The more you expose yourself to this stuff, the better it is. But at the bottom of this, right, we kind of already highlighted this section. There's concrete strengths and mixed properties. And we're talking about foundation concrete, right? So here we are. It talks about all the different concrete types and the different types of strength that you need. Aggregate size is the biggest rock that you can use. This weight is either NW or LW is lightweight, but this project is all normal weight. And water cement ratio, that's something from the mix. It's how much water they can put in the mix of the concrete. But really what you guys are trying to get to is, hey, what's the strength of the foundation concrete? Well, it says 4,000 PSI. So that's your answer. Say 4,000 PSI from concrete notes on general notes sheet. And if you want to put the sheet number in there, you can. That would be the complete answer. Okay? So when we talk about your scavenger hunt, this is what we're looking for you guys to do. All these questions, by the time you see them, they'll be supplemented with a couple of hints to kind of help you guys out a little bit. You, by all means, work together, work in teams. Everybody has to turn something in, but working in teams, it's a good idea to just, everybody can kind of learn how to navigate drawings. I'm going to go through one more just for fun because it's a little bit tricky. I know this one's a little bit harder, but if we go down to question 6, what are the dimensions of TB1? You probably look at this and go, what the heck is TB1, right? Again, that's one of those things I highlighted in a little intentionally here earlier, but TB1, you go back to the foundation plan. Actually, go back to the plan notes. It's the first time you see TB1. And that's why it's important to read these notes and really pay attention to what they say. So if you read all these notes, in the foundation notes, you'll see TB. TB indicates tie beam per FS 3.3. Okay? So you can go straight from here. You can go to FS 3.3, which is this section right here. And you'll see there's 2 different types of tie beams. There's tie beam 1 and tie beam 2. We want tie beam 1. It's asking for the dimensions. So the dimensions in our terms are generally length and width. And it's showing here, you see the width of it's 1'6". The depth of it is 1'6". So the answer to the question is 1'6" by 1'6". Okay, so you say 1'6" by 1'6". How did you get there? Plan notes define TB and reference FS 3.3. So section FS 3.3 gives you those dimensions. Now, if you wanted to find those another way, ultimately, when you're talking about size of members, that's one of the things I said earlier, right? Sizes of members, if you knew a tie beam from looking at the foundation plan earlier, that you see these, here's TB1, here's a TB2, again, you can get to the same place. So even without knowing what TB stands for, if you look for it on plans because it says, hey, what's the size of it? The size of it generally would be shown on the plan, or at least you can start at the plan to figure it out. If you go to TB1, you can get to that section FS 3.3. So there's lots of ways to do things, right? So in summary, again, just want to remind you guys, watch the video on just drawings and how they're put together and view types. That'll be very, very handy for you guys. Remember the order of where you want to start looking for things. And I'm probably going to supplement these a little bit to talk about the types of things you'll see on each. Remember what these symbols mean relative to those view types, sections, elevations, and details. And then get through these drawings and have fun, all right? It's going to be a good learning experience for all you guys. I hope you find it useful. And then if you have any questions, by all means, submit an RFI to the board and we will respond accordingly. Thanks for your time, guys.